Welcome back, my friends. On today's lecture, we will talk about defining the materials necessary for our model. From the ribbon of menus, you click on Define, you choose Material Properties. A new window will emerge for us. The Define Materials windows in ETABS is where you set up and manage the materials for your structural model. Materials define the physical and mechanical properties of the components in your structure, such as beams, columns, and slabs. Let's take a closer look at the options in this window and how to use them. On the left side, you can see the material list, which here you can find the A99FY, which is a steel material commonly used in structural steel design, and 4000 psi, a concrete material with a compressive strength of 4000 psi. We will change that material since our units are in the international system of units. And the A615GR60, a grade of 60, reinforcement bar materials with a yield strength of 60 KSI. A416GR270, a pre-stressing steel material. You can select any material from this list to modify it, or you can add a new material. By today, we will add a new material. So you click on Add a new material, and you click on OK. You name your material C25, let it be concrete of a grade 25 megapascal. You click on concrete. Your material directional symmetry type, you will choose it isotropic. We have two types, isotropic and orthotropic. Those behaviors for materials, you can check them on YouTube to find the difference between them. The concrete is an isotropic material, so we choose isotropic material. Material weight and mass, you can specify weight density or mass density. We will use weight density since we want to find the reactions of our model by kilonewton. Weight per volume unit, we will consider this 24 kilonewton per cubic meter. Modulus elasticity, you can customize this option by clicking on the label, deleting the existence, and using the equation of 4000 times the square root of f prime sub c, which is the compressive strength of concrete. The square root of 25, it will be 5. So you click enter, you will have the value. Or you can type 25 to the power of 0.5. You will have 23,500 megapascal. Here you can assign Poisson's ratio, taken for concrete, 0.2. You can also surf YouTube to read more about Poisson's ratio, or you can review strength of material or mechanic of materials. Here, the coefficient of thermal expansion by default, ETABS take it by default, and here the shell modulus is automatically calculated by using modulus of elasticity and Poisson ratio. Design property data, you click on modify, show material property design data, and you specify your concrete. Since it is normal weight concrete, we will customize it by 25 megapascal. Here you have an option for lightweight concrete. Since we will not use lightweight concrete, we are using normal weight concrete. We will keep it as the way it is, and we click on OK, and we click on OK again, and here we have our material. We will add a material for rebar. You choose from here rebar. If you don't want to choose, there's no problem. You click on OK, and you customize it by this window, the material property window. You click on rebar. You name your material FY 400 MPa. I suggest for beginners to leave the material properties as the way it is, since you are beginner in defining materials and using ETABS. We will talk deeply about defining the materials in the next sessions and in the next models also. So we hit on OK, but first we change the material properties. Since we took the FY 400, we type it 400. Minimum tensile strength, FU, it's 50%. of the yield strength, and the expected yield strength, it's 10% of the yield strength. And here you have the expected tensile strength. It will be 1.5 times 1.1 times 400 megapascal. You click on OK, you click on OK, and there you have it. You defined your steel material, rebar material, and concrete material. Click on OK. See you on next session.